Hi everyone. In this video, we will cover the basics of shader types in Maya. Now, shaders and materials are two words that tend to be used randomly in Maya to refer to the same thing, and that is the actual surface of objects and the way they interact with your scene, with lights, with color, and therefore make how we see these objects appear within a scene. So when we talk about an object, refer to an object being shiny or an object being dull, rubber-like, transparent, those are the things that we defined as the materials of the object. Now, to create these materials, we use something called shaders. Now, shaders are how we apply that material onto the objects. There are many types of basic shaders, but the most commonly used in Maya are included within the rendering tab. Right here under the rendering shelf, these little circles are the shaders that we use. The first one being anisotropic. Then we have blend materials, Lambert, Phong, Fong-Yi, and so on. Now, Lambert is the default material that the program uses. And that is because that is a material that all these materials are created mathematically, by the way. And they all refer to the way that the light interacts with the object. So what does that mean? Well, as you can see, you see these objects that are created within the scene. The fact that you see them means that there's a material applied to the objects. If there was no material, then you wouldn't see anything. That material that is applied is one of the nodes that appears in one of the attribute editor tabs for when I select the object. So if I select these two, you'll notice that the rightmost tab right here indicates that there is a Lambert node applied to that object. This node contains that shader called Lambert 1. Lambert 1 is the default material for the program, meaning when you create something, the program will automatically apply that Lambert 1 shader to anything you create. So by that same token, never change the Lambert 1 because it will change the way your program represents any object when you apply materials to it or when you create it. So how do you create these materials and what do they do? Well, like I said, the shaders allocate the mapping to the materials onto the surface of the objects. So what that means is anything that represents the way that the material of the object is supposed to look like is contained within them. So in this case, let's take a look and how do I apply those objects? You can simply go ahead and click on one of these to select what you want to apply to that, or you can switch your menu from modeling to rendering, and under lighting and shading, let me untag that, you'll see that you have assign new material, favorite materials, existing materials, and by the way, because Lambert 1 is the default, it's already existing, that you also have a list of assign favorite materials, which the program gives you by default, and those match these guys right here. And you can also, the way in my workflow is I use the marking menu. I simply right click on the object, and from the flyout menu at the bottom, I have the exact same selections. So it's 3 points of entry that get you to the exact same spot. So in this case, let's go ahead and get started with a Lambert material. So I'm going to go ahead and assign a Lambert material. So from the list, simply go select the object that you want to apply a material to, then go to assign favorite and apply the Lambert shader. Now when I do that, basically my name changes here and new tab. It's created for the attributes editor for that object, and it's called Lambert 2 by default. Without delay, and make this part of your workflow, change the name of the material to something that matches what you're trying to create. This will make your life a lot easier. If you leave the names, they will be numerically named, so they'll be Lambert 2, Lambert 3, Lambert 4, and you will never know which one is which. So you want to go ahead and give a name to each material as you create them. So for example, if I were to make rubber out of this, I would call it rubber underscore matte is what I usually call my materials. I give them an underscore matte so that I can quickly recognize the node name when I'm looking at the overall mapping of my project. So now if I want to go ahead and I can change settings for this, I can go ahead and all of these properties are within that the material attributes within the color area. This is what we call the color options of the object. Lambert is one of the basic materials, meaning that it doesn't have any what we call specularity. I'll explain what that concept means in just a second. For now, know that any material that you create with Lambert will look dull. It'll look like rough clay or like rubber. That's basically what you will have when you create this material. You can affect the color by clicking on the swatch and applying a different color or changing it from the slider down here to a color that you like. You can also enter HSV values, hue, saturation, and value on that to change the colors. You can also switch that to RGB if you want to go ahead and click on this drop-down menu, RGB 0 to 1 or RGB 0 to 255, depending on how you're working. So you have options. You can also work with this color wheel. So you can apply any kinds of colors through that option. You can also affect how much color is applied onto this object by increasing or decreasing that value. You notice that I went down to 0 and then I went back up to 1. By the way, all of these color sliders, all of these are weights, meaning the values that you apply in here average to 1. They never go beyond 1. So this goes from 0 to 1. So now that you notice that I went to 0 and went back up to 1, the program lost track of the color that I had chosen and it went back to defaulted to 1, to white, sorry. So I can always go back into the swatch window, click on the color that I want, and it gets applied. Now, I also have transparency values for this. So the higher the number, the more transparent the object becomes. Then I also have ambient color. Ambient color refers to all the colors in the scene that will affect the way the color looks to you. So as I've explained before, the color that you see in an object is basically the reflection of that color in on the object. So the color material will absorb all colors except the one that is reflected to you. And that one that you see is the color that basically you determine that object to be. Therefore, you can affect the color, the way the colors are being reflected of that object by changing the ambience, the amount of color that is the overall color in a room. So for example, if I'm in a room and I turn on the lights, the bouncing of the lights from the walls determines the ambient color in that room. Incandescence refers to the ability that we have to increase the amount of what we would call tint in print, or the amount of the levels, increasing the levels value of that specific color. Now, when we do that, this basically makes the color move towards white, but it does not create a light source. So even though it might look like it's irradiating light, it doesn't irradiate any light from the incandescence. You can turn an object into a source of light, but that is something that we're going to see in the class when we go into the lighting portion. You have also, let me bring that incandescence down, you have also something called bump mapping that allows you to apply textures that will affect the topology, or at least the way the topology of the object looks on your scene. So for example, if you want to create something that looks rough or that has holes in it, or that has a texture like, let's say, the grid on a microphone, or the texture of a wall that has kind of like that orange peel look to it, you apply that through bump mapping. The way that this works is the program will mathematically calculate what the light bouncing of those depressions and bumps will look like depending on where the camera is, and it will create a fake version of it by using light and dark values. To the naked eye, it will look like you actually have detailed topology on the object. But if you go close to it, you'll notice that there is no such topology, that it's actually a trick of the eye. Now, for the most part, this works really well, and it's what is used in order to render fairly fast without having to add a lot of geometry within your scenes. Diffuse refers to the amount of color. So diffuse and color basically go hand in hand. Where color determines the color that is bouncing off the object, diffuse determines how much of that color is applied to the object. So if I go all the way full-blown to 1, I'm seeing the full amount of color that is determined within the color. If I go to 0, then I'm removing all the color and it goes to black. Okay. Then you have translucence, which refers to the way the light actually works across that material if the material was semi-transparent. So it's something similar to subsurface scattering, and that's a concept we're going to be talking about for other materials when we talk about Arnold materials in the next video. And you can control all that translucency from here. I would never use Lambert for a translucent material, but it's there for a reason. Now you also have the ability to add special effects that include glow intensity. And again, this glow intensity refers to what the material looks like, but Lambert materials will never turn into light sources. You only achieve that with other materials. And you have the ray trace options. You also have matte options, by the way. Matte options refer to the ability for you to actually apply, along with transparency, materials to this that will create transparency onto the object to control how much of the object you see or don't see. Now you have ray trace options, and these ray trace options refer to the ability that you have to apply refractions or affect reflections on the object. This ray tracing is what gives the material the ability to turn metallic and shiny or something that is completely reflective like a glass. That's what, for this type of material, will allow you to do that. And you need to activate this ray tracing option in your rendering settings. I will show you how to do that in order to achieve the reflections. Now, this is basically the brief overview of what Lambert Materials does. Now, let me go ahead and change. Notice that we didn't have anything that says specularity here. Specularity refers to the, basically it means the quantity of three-dimensional rendering, which represents the amount of reflectivity of a light on the surface of the object. So what does that mean? It's that highlight that we see on an object that tells us whether the object is metallic or it's made of glass or it's made of a more rough material, something that is soft or hard. That reflectivity, that amount of light that is bouncing off the sheen of the object, that's what we call specularity. And that specularity is something that we control in order to create the materials the way we intend them to look. So for that, you need to have a different material than Lambert. The first material to have specularity within our favorites is Blinn, which is this one. So for that one, I'm going to apply it this way. And you'll notice that as soon as I apply it, let me only select the cone and keep this one deselected. Remember that I applied the material to both of them. So if I change the material in one of them, it will affect both of them. And I see now that with the cone selected, I have the Blinn material node on my attributes editor. I'm going to change this one and I'm going to call it Shine Matte just for now. And that's just the name. I'm just coming up with names as I go. So I can change, like with the other one, I can change the color of the object. So if I can go to green, for example, I can change transparency, ambient, all the other stuff. But the basic material attributes are very similar amongst the Maya basic shaders. They are pretty much the same. Where this becomes different somewhat is when you come to Arnold materials, and we're going to talk about those in detail in the next video. But notice that a new tab appeared under the material attributes, which is specular shading. Now, specular shading, like I said, reflects to this highlight and the reflectivity of the object of that light within the on top of the surface of the object. So this eccentricity value allows me to increase how wide or narrow that shininess looks on the material. Now, you notice that if I spread it by increasing the eccentricity, my material tends to look a little bit diffused. It almost looks like it's got some kind of rough surface on top of it. There's some roughness to it. If I bring it down, then it starts getting really shiny. And that is because the reflection of this thing, of that light, makes it look so. So the way that light spreads on top of the surface of the material will determine how shiny or how rough that surface looks. You also have the ability to change the roll-off, the distance, as how the shininess, the glow of it, how it appears, whether you want it to be completely around or reduced. You can control that. You can control the color of the specularity. I'm going to keep that white for now. You also have the ability to have reflectivity in these objects. Now, for reflectivity to work, you need to turn on that ray tracing option that I talked about over here. So you have ray tracing like you did on the Lambert, but you don't turn it on from here. You turn that on from the rendering settings, and I'm going to show you that in just a few minutes. You have then the ability to control the reflectivity and the amount of reflected color. If I increase the reflected color towards white, what that is doing is basically using all the ambient color in order to be reflected with the object, and it's going to give a wash look to my colors. If I keep the reflected color in black, it's using something called something similar to basically including shadows, for lack of a better descriptor, within the reflections, so that you have more natural looking reflections on your object. Now, another one of the shaders that we have available to us is Feng-Yi, which is it's one that I use. By the way, all of these materials that we're creating, they all work with Arnold. So out of all the basic materials that we're going to see, Feng-Yi is the only one that I actually use with Arnold, even though they all work with Arnold. I prefer to use my materials as Arnold materials. Now, in terms of CPU usage, Arnold materials use more CPU power to render than these do, but they produce natural looking, more real photorealistic materials. So let me select these two guys and apply Phong E to them. I'm going to go ahead and select Phong E. And the names, by the way, are given by, in some instances, by the last name of the mathematician that came up with how, I mean, the people, the physicists, sorry, that figure out how the light works, bouncing of the object. In some other instances, it's just by the name of the mathematical equation. So, I mean, they just have weird names. In this case, Phong E is the name of this material, and I am going to change this one to, let's say, glassy matte, just to call it glassy matte. Notice that it has the same settings as the others. It has common attributes, which are the color, transparency, and so on. I can now, under specularity, instead of only having the weight of it, I have roughness applied to it, which if I select the shine material, it would be the eccentricity in this case. So you have the ability to control that over here, but it has a different name, and that is because the equation, the mathematical procedure to do it, whoever worked out that gave it a different name, but the end result is basically the same. You have highlight size, which is the diffusion of the highlight, as we saw in the other one. You have whiteness, specular color, reflectivity, and so on. And underneath that, you also have ray tracing options. So let's, for example, increase the reflectivity of this guy completely high. That's this material. And I am going to make the highlight size smaller to make it look shinier and less rough so that it is completely shiny. Let's go for something like this. Let's decrease that size of that. Boom. So I'm not going to go all the way to 0, as you notice. Basically, if I go to 0, it just disappears. Now, I can go to 0 on the highlight size, or I can go all the way to 100, and you'll see how that basically disperses the light on the surface. Okay, so let's go ahead and do this. Keep this as is, and let me set this last one here, and I'm going to apply the very first over here on this list, which is the anisotropic. And you'll notice that the anisotropic, basically what it does, it basically creates a shader that creates this elongated material, elongated highlights, and they are reflective of what you would see on materials like brushed metal, where you have the texture of the material change the shape of the highlights. So that's what these give you. That's basically the difference with this material. And you have a tab for it. So I'm going to keep this one as is for now. But over here, besides the material attributes, under the shading, specular shading, you have the ability to change the Fresnel index, which determines how bright or how dark that is, that shininess is, how rough you want it to be, and you'll see what effect that has on the material, on the object. So you can have a very shiny object with a low rough number or rough value, rough weight, roughness weight. That's what it's called. These are called weights. You can spread on the x-axis, or you can spread on the y-axis, so you can change the direction of that anisotropy. And you can change the angle as well by rotating it. So you have the ability to control quite a bit on the way this object reflects light from its surface. Now, in order to see how these objects reflect onto one another, like I said, number one, in order to render anything in Maya, you need to have lights. By default, the program has lights set up, which are called the use default lighting. They come on by, simply creating a scene. So you have some default lights that the program ceases to use or stops to use as soon as you put a light into the scene. For now, I'm using the default lights. But if I were to turn off all lights, then everything goes dark because the program is assuming that I have some kind of light in my scene. Since I haven't created any lights, it's going to say, okay, well, it's dark, and you said you'll use all lights. I'm expecting you to create one. I'm going to keep the default light for now. And in order to render, you have 4 different rendering. By default, you have 4 different rendering engines inside Maya. You have the Maya software, Maya hardware, Maya Vector, and Arnold. They are all different, and they offer different options on how to render. The top most used rendering engines with the default settings are Maya software and Arnold. Maya software will respect this ray tracing options. Okay, ray tracing options refer to the ability, how the material interacts with light, either to reflect it or to refract it. Refracting light, or the refractive index of an object, refers to how the object bends light. So if you have glass, as you see, for example, when you put a straw in a glass of water, you will notice that the surface appears to break visually, break the straw, but it doesn't really do that. Basically, that is the light going through the water and reflecting on the other side and playing that trick on your eye. That's called refractivity. And that refractive index is based on the type of material that you're working on. So you need to, if you're trying to create an object, you need to determine what the index of refraction is for that object. And if you do a quick search online, you'll find that there's tables of index of refraction depending on the materials that you're trying to create. So let's go ahead for now, and let's go ahead and access where we render the render window so that we can go ahead and change the settings to activate ray tracing. So if I were to go ahead and click on this little clapboard up here, they'll tell you where you can render. The very first one is up. We're going to go into more detail in a future video into these. For now, I just want to show you what this looks like when you render. If you open the render view, you basically have a window. Inside that window, you have the option to choose what rendering engine you're going to use. For now, the default one is Software Maya. If I click on this clapboard on the left-hand side, which is the same as this one here, I will do a quick render of my scene. And you'll notice that everything that I have on the scene appears right here. Now, if I go ahead and say, okay, I have increased my reflections in these objects, let me go ahead and say my reflectivity for this object here. Let's go to its material. I want to make sure, see, my reflectivity for that is 100%. It's 1. So why isn't it reflecting of anything? Well, the reason for that is because in order to do that, you need to activate that ray tracing options. So to do that, we're going to go into this tab right here, the one that has a clapboard with a little gear. When I click on that, this window opens. This window is the window for your render settings. And depending on what rendering option you have selected, which render are you using, this will change. You will have some that have more tabs, like the Arnold one, for example, that have several tabs, and you can affect a lot of different attributes on how to render an Arnold, which makes it great. It might sound like it's more difficult, but actually it makes it easier, because you can hone in into the way a material looks fairly fast. Let's go to Maya software again just to see the basic. And you'll notice that you have common settings. Like I said, I will walk through this in a future video. I just want you to open this and know where it's at. So then I'm going to go to the Maya software tab, and notice that right here we have also a lot of options for anti-aliasing, the way the different fields, if you're working with sending stuff out to video and so on, works. And ray tracing. Now, when we go to ray tracing quality, you'll notice that ray tracing has been turned off. It's by default turned off. So if I turn it on, now I have a whole bunch of settings on how to handle reflections, refractions, and so on within my scene. Let me move this out of the way for just a second, and let's re-render this scene right here. So I'm going to go ahead and click on the clapping board again, and you'll notice that now I see reflections on my material. These objects are being reflected, and these objects are being reflected on the other object right here. So I have the ability to now, let me zoom in, let me close this, zoom in a little more so we can better see this, and go ahead and render the scene once again, and you'll see all the reflections happening. So you have the ability to control those reflections by simply activating the ray tracing options under ray tracing quality in your Maya software. That is for Maya. But if I were to say, switch this to Arnold Renderer, close this, and notice that this got changed, the engine got changed to Arnold Renderer here as well. If I run a render, everything's going to be dark. Now, the geometry is in there. That's why it took a second for it to render, but it doesn't see anything because there is no light on the scene. And for Arnold, we need to have lights on the scene. It will not use the default lighting set that Maya comes with. So that's something to keep in mind. Now, the same way that you're seeing all this, basically all of these material attributes, the way it works best is by you setting up your scenes and then testing, keeping that rendering window open, whether you're working with the rendering window by clicking on this, clapboard to open it up and say, for example, going back to Maya software and then as you make the changes, click on this one to do that, or by using IPR, which is basically a dynamically generated render, which allows you to make changes, and in a zone that you have selected here, it will show you the changes that you're making. Or if you go to the Arnold window, you can also activate a window like this one for Arnold only. That allows you to render based on the Arnold engine only. So we're going to talk about that in the next video. You can also change the rendering, this window to be a rendering window. Now that slows down your program a little bit, but it gives you a visual representation of what this is going to look like when you go to final render. So you can go under renderer here, and if you click under renderer Arnold 2.0, I'm under renderer viewport 2.0, you click Arnold, you'll get this little window that allows you to click on this play window, and you'll notice that you have right there, you have render within the scene, you have used the Arnold renderer, and if you rotate this, it'll keep on rendering, but you can't see anything because, like I said, we don't have any lights over here. But if I had lights, I would be able to see the render as the rendering within my perspective viewport, the final render, not the final render, but whatever I have set up at this point for Arnold. So that's an option that you have. To turn that off again, go to renderer again, click on viewport 2.0, and you go back to the default rendering engine that you might have at this point, which is Maya software. So that is the basics of how to apply and manipulate the attributes of materials onto objects. In the next one, we're going to talk about Arnold and how to work with Arnold, and then I'll go ahead and start introducing transparency so we can work with glass and such in order to add materials to the different models that we have been created in class.